Alright, so the problem for chapter 6 says a lighthouse beam emits a light that has a wavelength of 514 nanometers. What is the energy of one photon? Then part B, using that answer, how many photons are emitted if 2.2 times 10 to the negative 3 joules of energy is used when it turns on? So for this question, you have to know a couple different things just to start off with. First is going to be the equation to find the frequency, which is speed of light equals the wavelength times frequency. And then once you have your frequency, you have this equation, which is the energy of one photon equals Planck's constant times frequency. So Planck's constant is equal to 6.6 times 10 to the negative 34th joules second. And then the speed of light is 2.998 times 10 to the ten to the 8th meters a second. So for the first step, you got to find the frequency, as I said. For this, you pretty much just plug in the speed of light as c equals the wavelength, which is given 514 nanometers, times v. But the only thing is that you have to remember is that you have to make them both meters. So you have 514 nanometers times 10 to the negative 9th meters over 1 nanometer, just to make the nanometers cross out. You then divide the speed of light by 514 times 10 to the negative 9th nanometers, and you get the velocity as 5.83 times 10 to the 14th. You then take that velocity and plug it into the equation for the energy of one photon, which is Planck's constant times times your frequency, and you get 3.86 times 10 to the negative 19 joules. And then for part B, you got, using that answer, how many photons are emitted if 2.2 times 10 to the negative 3 joules of energy is used when it turns on. So for this, you just got to do, you're given that 2.2 times 10 to the negative 3 joules of energy is used. So you got the joules of energy times one photon over your answer from the last equation, the frequency, or the joules from the last equation. So multiplying that times 1 over 3.86 times 10 to the negative 19, you get 5.7 times 10 to the 15th photons.